Let's go ahead and get rolling then. So I already took a survey of the room, but Zoom chat, I'd be curious, how many people here are familiar with React already? How do I make the thing come back? Oh, see, I don't know. Now chat is completely gone. They keep changing. Oh, wait, here we go. I know, I had it like, oh, here we go, chat. Sweet. All right. If we don't have anyone, if we have anyone who's not familiar with React, also for the recording, so if people don't know what React is, just a very, very brief thing. It is the most popular JavaScript library for building UIs. So the reason people use React versus something else, React, you get dynamic data. So you can have variables, you can insert them into your HTML. It just kind of more or less magically updates. We're going to unravel some of that magic today. And there's some other alternatives, but React is the one that's the most popular. Definitely, if you want to get employed as a web developer, it is a good thing to learn. So the first thing I want to do is just set up a basic React project. There's many ways you can do this, but the one I'm inclined to do is use Vite. So Vite is just kind of a somewhat newer, very actively developed basically bundler that will let you like set up many different kinds of projects. So you see it has some different options here. So if you have npm installed, you can just run this command. You don't have to have anything else installed. Npm init Vite at latest. Let me make this a little bit bigger too, just in case. So it's more readable. And it'll give you some different options. I'm going to call whatever, you don't have to put React reimplementation. That's what we're going to be doing, is writing our own kind of duct tape grade version of React. But we're going to start from an existing template of what React is, and then we'll slowly take one at a time, re-implement each piece. So go ahead and pick React. I'm also going to do TypeScript just because for doing something like this, it's useful to be able to specify some types. We might have to work around TypeScript now and again if it's not smart enough to keep up with us, but should be good otherwise. So if you run that, it should set up the project. It should not take long for this to happen. You might need to like npm install something if it says to do that. But I'm going to go ahead and run npm install here, grab all the dependencies for this, and then we'll take a look at the initial page and sort of start poking around into React. So go ahead and run that. Let's go ahead and kick up a dev server for this. Oh, was I? Okay, yeah, sweet. So open this up, go ahead and open this up in your browser. So the Vite template is a little bit different from like Create React App. If you use that, it has a button. We can tick up things. So this is one important feature of React, right? useState, if you used it before. It's a way to manage some small piece of state, develop that. So we got that. Let's go ahead and take a look at the actual code for this. So here's our initial file. We have lots of different divs. Here's our useState. We're going to be running that today. But the first thing I think we really need to deconstruct if we want to learn how does React work under the covers, how do you make it yourself, is how does JSX actually work? So does anyone actually know this? It is in the React docs. So if you've read through those, there's a chance you might know. No? Okay. So JSX, if we want to actually explore what this is, something that you can do in React is you can just assign an HTML or JSX element into a variable, right? So if we do this, what is actually inside of A here? That's what we want to find out. So why don't we just console log and take a look? And let's go ahead and pop out our dev tools. Dev tools are going to be super useful for helping us get through this. Okay, over here, we can see it's printed out twice for reasons that aren't important right now. But what all this actually is a plain old JavaScript object. So it has a number of interesting properties, $, type of, under a lot of underscore things we don't need to worry too much about. The important things are this props and this type. So when you create a regular HTML element in JSX, it actually makes this object that basically has a structure of what kind of the type of what it actually is. and then whatever props are being passed into it. And so this is just purely a syntax transform. That's why you'll hear people say things like, oh, what is JSX or what is React? It's just JavaScript. It's not just JavaScript. JSX is not part of JavaScript. But the reason why they claim that is because you can trivially take any piece of JSX and convert it into equivalent JavaScript. One way you can actually for sure see this is true is if you head over here to the React docs, right, which are great, by the way, and go down here, you can actually use React without JSX. Almost nobody does this, and there's almost no good reason to do this. But you can, in fact, do it. And if you read through here, it will show you how to actually do this. So if you want to, here's a little small. But if you want to create a div with hello world in it, you can do it by doing React.create element. And then let me see if I can, here we go. And then that's the bad example too. Here we go. React.create element, and then a string with the HTML tag name. This is your props, so it could be null if there are no props. And then any children in the list at the end of that. So when you have JSX, it's just getting converted straight into a React.create element call by your bundler, compiler, whatever setup you have. Now, how do they handle components, right? So if we write a function component or a class component, right? So if we go and say, hey, we're going to have some component, right? And then inside here, let's say we return a div or whatever. If we use this component, we can use this in JSX. So if you're not familiar with React, this is how you can reuse code. So if you want to have like the same button rendered multiple times, right? We can render this component multiple times in the tree, and this will work completely fine, right? So if we go over here, we get our 3 divs with hello. So how does React translate that? Because a component is a function. It's not actually just something that's built into HTML. And that's what the second example here is showing. So if you have a component, instead of a string, that first call, JSX will transform that into just a reference to that function. So you're just going to, if you've used higher order functions before, that's what's going on here. You're just having that a reference to that function passed into React.create element. And from there, they can figure out, okay, if it's a string, do this. If it's a function, do that. So that's what we're going to do next. If it's a class, the other thing you might be worried is how does class components and function components work? Through some kind of deep JavaScript trickery, you can in fact figure out whether a given thing is a class or a function. And so that's what React actually does internally. We're just going to focus on function components here, but everything you can do here in principle, you can extend to class components. And if you were like writing a real re-implementation of React, that's what you would want to do. The other thing that can happen is there's like React fragments. So if you've used that before, it's like the empty tags. That also has a special representation, but I'm not going to worry about it too much here. Once we get through everything today, you'll be able to see how you could pretty easily implement that yourself. So what does this React.create element actually return? That's what we're getting over here. It's returning this object. All this is a very simple, basically transform. So it takes this function name, it takes the props, it takes any children, and it converts it into this data structure over here that we're seeing printed out. So we can actually stub this out ourselves. And that's what we're going to do next. So how do we write our own React.create element? So I'm going to actually go into main.tsx, which is this is the root of a React project. So you may have never actually dealt with this if you just kind of had a template pre-generate things. But at its core, what React actually does is it creates one div on your page with an ID of root, and then renders your app into that div. And so let's go ahead and start stubbing some things out. In order to do this, we need to, for this React import, we need to change the mode our compiler is in. So modern Vite and a lot of other build tools will automatically import from the real React, just so you don't have to do import. So like if you check our other file, I believe they do this. Let's see. Yeah, here you import useState, but you don't have to actually import React. If you used to use React in the past, you'll know that you always need to make sure you imported React and you get the squiggly line about unused, but it's actually not unused because after the transform, you'll have a bunch of React.create element calls all over in your JSX. And so to get it to go back to that old mode, we're basically just going to write a little comment that will tell the compiler what we're trying to do. So I believe it's at JSX. Let me grab this from my finished one. Here we go. At JSX runtime classic. Very inscrutable string. Usually you would never want to do this, but for this, it's pretty useful. So go ahead and add that comment to the top of this, and we'll also need to add it to our other file. So let's open up main.tsx, add it in here. And what this will let us do is actually like mock out this import. So instead of importing React from the real React, we can import React from ourselves. So over here, I'm just gonna import React. Well, let's create React over here. So we know what the structure of React is, right? We need to be able to call React.createElement. So let's just actually create an object that matches that shape. So we have a React object. Let's just get rid of this guy, don't need him. And let's export this so that it's accessible in our other files. All right. Great. So we've got that. We've stubbed this out. Let's also get rid of this React.strict mode. If you haven't run into this before, that's basically a special opt-in mode of React that has some additional checks to make sure you're not doing things that aren't explicitly forbidden necessarily, but are probably not what you want. But they had to provide it in a backwards compatible way. So they give you React strict mode, you can wrap your thing, but we're not going to worry about that. If you do bad things in our implementation of React, it's probably just going to crash with an inscrutable error message. Okay, so now that we're actually doing this create element, what is the implementation of this guy? So we know what the React.createElement calls are going to look like, right? We're going to get this first parameter, which is like, we could say this is the type, right? Then the second parameter will be our props. And then the way that this actually works is if there's multiple children, it's maybe a little confusing. I don't know if there's a good example on this page, but if there's multiple children, here we go. It's not made into a list. It's just, they just have multiple arguments extending past the end, right? So in order to actually take all of those arguments, like if you were to have, the way that a call like that is going to look is like, say we have a div with two things in it, right? So no props, but if there's a child of 2 and there's a child of hello, then it would look like this. And so in order to handle that, you can use our rest syntax. If you haven't seen this in JavaScript, it's a way to take all the rest of your parameters and gather them into an array. And I'm actually going to call this children because that's what it is. The other thing to note, let's go ahead and write like what this would look like if we had like a nested div. So if we had a div and we had another div inside of it, then what's inside of that is just another React create element call. So say we had another div inside of it and that div has hello world. Then that's the sort of thing you would end up with. Okay, so now we've got this. TypeScript is going to be super angry that we don't mark any of our types. So let's start annotating some of the types. This guy is going to be one of two things. So it could be a string, right? If it's like a div. It could also be a component. So we can try to like write an inline function type here, but it's going to be a lot easier if we just write the type up here. So for this, let's just say function component. And what is the type of a function component? Well, it's going to take some props, which could be anything. And the type of props is actually an object. So for now, let's just leave that as any, and we can refine it later if we feel like that suits us. And then what does a function component return? Well, it returns one of these created React elements, right? So whatever you want to call that. So I'm just going to call that React element, but you can call it whatever you want. In fact, a better name for it might be like React tree, because any React element can have more children it's basically a tree-like structure, right? So it can have children who also have grandchildren, et cetera, et cetera. So we'll call that React tree. And then let's write a type for that as well. So just a very basic type to get started here. And let's just mimic the shape of what regular old React is. Oh, it's gone now. It's angry because we destroyed our imports. But if you recall, basically the important things where we had a type, right, which could be like a string. We had props, and inside of props there was children. And then what is each one of those children? That's just another instance of this. So this is, you have a recursive type. So each child has an array of basically children inside of it. And then there can be other things in here too. So one way you can notate that in TypeScript is to do this record syntax. So you can say, I think it goes like this, key string. And then the value of that could be anything. So we'll just use unknown. If people have seen any before, so TypeScript, you have any and unknown. The difference there is just that any will let you treat it like it's any type. So if you have something as any, you try to use it as a number, fine. If you try to call a method on it, fine. Unknown is like a type safe any. So it's like, we don't know what the type is, and TypeScript won't let you touch it until you actually figure out what the type is through some kind of operation. So I would say generally favor unknown, but if you're just trying to get things working, then any can be useful. Okay, and this looks pretty good. So we've got a type for a function component. And so now we can go down here and say, okay, this guy's going to be a string, or it could be a function component. All right, what are our props going to be? This is going to be another record, right? It's going to be an array that could be anything. Let's just go ahead and mark that as any for now. We can come back and refine the types if we have time. And then children, what are the children going to be? Those are going to be this more React elements. So maybe the best thing to do would be if this data structure is going to have, like, let's make a type that represents what create element actually returns. So that, which is this React tree actually. And so we should be able to do React tree. This should be fine. Something like this. I'm trying to remember what I did before. Let's see if this looks okay. String function component. Let's just start working through it and we'll see if anything goes wrong. Okay, and then to actually implement this, we're just gonna return an object that matches this shape. So this whole thing is supposed to return a React tree. And so what do we need for that? We need a type, so we just pass in the type. We also need our props. And so our props are just going to be our existing props, but we also need to put children inside of here. So put that guy in there and then have our props. Let's see, type string function component is not assignable to type string. So here's a mistake here. This can also be function component. All right, and that seems to type check. That's pretty good. So let's try to restart our application here and see what blows up. I'm going to restart the dev server. Beat doesn't super like when we hot swap everything out on it. Let's see, objects are not valid as a React child. Object with keys. You want to render a collection, use an array instead. Oh, this is because we're still calling into React DOM and trying to render this out, which is a mistake because it doesn't know what to do with our fake React. So let's comment that out. Just get rid of all of this for now. Or even better, why don't we just stub that out so we don't have to worry about it? So same thing, we're going to do the same thing here. Let's just make a fake React DOM. Let's add a create root function. And for now, let's just do nothing. We'll just take anything and do nothing. Oh, but it still wants us to return a thing with a render. Okay, to make it happy, let's return an object with a render in it, which will also do nothing. I just want to get it into a basic compiling state so we can see what this actually looks like. Let's restart our dev server. Okay, it's no longer crashing. That's a good sign. So we've completely removed all of the actual React from our program. If we want to verify this, why don't we just go ahead and npm uninstall React? Boom, it's gone. Does it still not crash, it builds. So we have completely removed React from our application and we're on our own now. Okay, so let's go back into our main.tsx and let's start not stubbing so many things out. No, what is this? Expected 0 arguments, but got 1. Oh. Okay. So for our create element, to make sure this is actually working correctly, let's just go ahead and do a log of what this component tree actually looks like. So when we, like, for example, for this render, let's just console.log what we get, which should be this app. Remember, this is just being compiled into a React.create element call, which we have now intercepted and written our own version of. So if we log that out, we should be able to see the actual result of this. And okay, there's a lot of stuff going on. Really doesn't like what we're trying to do here. Okay, and here we are. We can see we've created this object successfully. So we've removed React from the equation. We have this object with props and some of these other random things inside of it. So that's pretty good. You'll notice that some of the internal React properties, like that $$ type of and stuff, have disappeared. So that's how you know for sure that we're on our own here. Okay, so now that we've got that, we've been able to stub out the basic entry points to the app. We've intercepted React.create element, written our own version of it. For now, it's working pretty good. How can we actually get this to display to the screen in any way, right? And so this process is actually fairly straightforward, but the algorithm's a little bit tricky. And if we take a look at the React docs, there actually are some interesting files in here, or some interesting pages on here that will show us how to write some of the algorithms. But for now, we can just work on getting it to render once. And so to get this to render once, let's first fix up some of these types. So this create root is actually going to be like a DOM element, right? So what you're supposed to pass into this create root is like the div basically that you're going to inject your entire app into. And so that is just a good old HTML element. Let's see, why doesn't it like this? Argument of type HTML element array. Oh, because we have this ... Okay, so we grab that. And then when we're doing a render, what are we actually taking? We're actually taking a React tree, right? We can't just take anything. So let's rename that. So we have that. And now we're in good shape. So in order to write this to the screen, the problem is that our data structure, we can't render things that aren't a div directly. So it's actually pretty easy to just render a div. If we want to just render a div into our root here, we can just add a child. So if we do append child, and then let's just create an element. If you've taken like a introductory course with the DOM or like web development, you've probably seen this before, right? You can just do document.create element and make a thing. And it looks suspiciously similar to our React.create element call. So I think the inspiration for that API comes specifically from the same DOM API. All React does under the hood is call DOM APIs for you. It just does so in a clever way. So let's just go ahead, let's create our div, and then we can put some inner text inside. Let's put hello world so we know we can actually see it. And then let's just inject that guy straight into the DOM. All right, so if we load this, you can see hello world has dropped in there. So all we need to actually do is take our tree, walk through all of the different nodes, build up what the real DOM should look like, and inject that to the screen. So how do we do that? Let's do it by writing a recursive function. So I'm just going to call it render to DOM. You can call it whatever you want. And what are we going to take? We're going to take a React tree. And we're going to return an HTML element. So once we have this tree, this is where we need to start doing some switching on the type, right? So if we have, the easy case is if we have something that is already a native DOM element, right? If we have a div, if we have basically this, right? we just have something that's a div, maybe it has some props or whatever, that's the easiest because we can just call React.createElement on, or we can just call document.createElement and get one of those. So let's handle that first. So if tree.type, and what we actually want to check is not what tree.type is, but the type of that thing. So if you've never used the type of operator, that will get you basically a string, which is one of these, 7 or 8 fundamental types in JavaScript of what it actually is. So in this case, if it's a string, then we know it in theory should be an actual HTML element. If you're actually doing this, you would want to validate that it was like one of the possible ones, like not just some gibberish element. But most React environments just won't let that even compile. So I'm not sure if they actually do this at runtime or not. But we're going to check if that's a string. And then let's create our element. And we need to create an element of type, whatever that type is. And then we'll just return that guy. All right, so that's pretty good. Oh, the other thing we need to handle, though, is that even though there are children that are more HTML elements, at the very bottommost level, you actually don't have HTML elements. So if you render, like, for example, if we have, let's say we have the following code, right? If we had a div that had hello world in it, right? If we convert this into JSX, what is that going to actually show up as? So we're going to have props be null. And then we're going to have the children. So I guess that would be actually in our props. And inside here, we're going to have somehow hello world needs to go in there. But hello world isn't actually an HTML element, right? It's just a string. So we have to make some sort of like pseudo fake element that can represent like strings and numbers, basic things that aren't actually HTML. And HTML does actually have an element for this. It's called text node. So if you do like document dot just create text node, it gives you back this thing of type text. So if you just, put in like hello or whatever, it will give you a node that just has like, it's sort of a pseudo, not a real HTML element, but sort of similar in some ways. And the type of this guy is just type text. So that's pretty interesting. So then what this actually means is that we're going to have to expand our definitions of what these things actually are, because how are we representing that right now with this React tree? It's not so clear. So let's actually create some more types. Let's just think about what a basic like string node would be. So if you had like hello world, what is that going to look like? Basically, the main thing is we would have whatever the value of the thing is, right? Which would of course be a string. The other thing we're going to want to have is a way to tell that this is a string node without just checking. Like you can check like, oh, is there a dot value? Then it could work. But what if other things have a dot value in the future? So it's kind of unwieldy. So typically what you'll do in TypeScript is you'll add like either a type, but we're already using type for something else. So we use kind to tell us what kind of thing this is. So we can just say string node, something like that. And then let's also create one for numbers. So then one for numbers will be like 99% the same. Except it will have a number inside of it. And then for our React tree, we now have to recognize that at the very bottom of some of these things, we're not going to get necessarily a straight up always another element. It could also be one of these node items. And let's actually check. I'm trying to remember exactly how they compile that so we can make sure we get it correct. They have this useful little online Babel thing. You can step it out and see. Oh, okay. They're actually, because it always, so here's the thing. It always has to be a child. And so they're going to just add it as a child of something else. So I think actually we won't need these until in a minute here. They're going to be useful. But let's go ahead and try this. So we have that. We know we can return our HTML element. So if it's a string, we're going to return a new DOM element with that stuff inside of it. What about if it's not a string? So if it's not a string, it could be a function. So if you have a function, hello, welcome, welcome. If we have a function, so let's check that. What you want to do is actually call that function to get whatever it actually is, right? So at the end of the day, every React element has to return real DOM elements, right? It can return other React elements, and those can return other React elements. But eventually, someday, you have to stop returning React elements and return a real DOM element that can actually be rendered. It has to be some kind of div or span or image or whatever. So what we do is we basically just make recursive calls until that happens. And so if we have a function, what we're going to return, for our DOM element is the result of basically of calling this. And so for this, we can just do, we know that the type is a function. So we actually just call that guy. And then the other important thing about this is when we call, so this is like our functional component, right? This tree.type is our function. It's a reference to our functional component. So that expects, what does it expect you to pass in? It expects you to pass in the props. So we also pass in the props from our grader tree. And it's going to say that we can't do this. Because we've said that a React element or a React tree could return, or React element, when you actually render it, could return another React tree. So let's figure out how we're going to take care of that. So right now, we have a React tree. If it's a function component, we're going to try to call it, and that gives us back another React tree. So probably what we want to do is actually look at the children and render those guys out too. Let me take a look at what I had in this originally in my working one to make sure that we're on the right track. This is the right thing. Yeah, I think this is right. Yeah, so if we have a function, we have to actually pull out those children and render those. So what we're going to do is use destructuring to pull that stuff off. So unpack this props. What are the important things? Children, right? We have to go and call all of the children if any of those exist. Is there anything else that's important to pull out of here? Maybe a couple things, but let's just do children for now. So in this children is just going to be an array of more things. And so what we can actually do is just use children.map this function. And that will give us the rendered children. So here's your recursion. So we take all of those React, all the different, so if you have a component A that uses like 5 instances of component B, when you actually render component A, what you want to do is say, okay, component A is trying to render out all these instances of component B. So let's grab those and render those. And then if there's anything below those, we also need to render the stuff that's below that. And then pass all of that in. So let's move forward from this. At the end of the day, what we need to return is some kind of HTML element. And so let's just go ahead and create that guy for now. And in terms of what that HTML element actually looks like, that is an interesting question. I'm trying to remember. And I apologize. It was late when I wrote this. I think we may have an issue with our typing stuff. Okay. I remember what I did. Okay. there's one step I forgot to do. Before we can translate into HTML elements, we need to go ahead and unroll all of the React tree stuff. So let's write a function to do that. Basically, what we want to do is go ahead and do the first. So we're going to do 2 steps. First step, take our React tree, call all the components. Then we'll have a tree that's only DOM elements, and we won't have to worry about this other case. That's what we need to do. So let's just call this function like evaluate tree. So this will take our React tree. And then what we're going to return is a new tree that is just like let's just call it DOM tree for now. And this will have just DOM elements. So what we actually need is another type for this. And that's where the string node and stuff comes in. So a DOM tree is a little bit different. It's basically just we're trying to get rid of this functional component, right? So we're only going to allow things that are DOM elements already, and it's going to recurse on itself like this. Okay. So now we can do if tree.type, if the type of that. So if we have a string already, great. We're just going to basically return the same thing, more or less. So if that equals a string, right? This is our case like this, right? So if this is the JSX that we're getting in, this type div, and then props with some children, stuff like that. That's great. And we can just return that same thing. So we'll do, what is our new type? Still going to be the same thing. What is our new props? Really, the whole object is going to be, well, not necessarily if the children are different. So that's what we have to worry about. So let's grab the children out of the props and then go from there. So if there's children, those could still be React elements. So maybe we have a div, but inside of it has component A. So that's what we need to do. We need to iterate over those guys. So for every child that are in those children, we need to go and call this something. And we can really actually just do this with a map. So map. Okay. And this will have a type of DOM tree, which will fit what we need here. So what we actually need to do is grab the children and then grab the rest of the props into a separate thing. So if you haven't seen this before, that's what this will grab the children out of that object, but then pack everything back up into REST props. So we can unpack those REST props and then have our children be the rendered DOM children. And we just need to make sure we return in every case. So that's maybe the easy case. If it's not a string, then we know that we have a function, right? So if we actually type this out, TypeScript will know that this has to be a function component. And this is where we go and call it on its own props. And what this will get us is another React tree. But we know how to render a React tree, or we know what we need to do for that. We just need to evaluate that. So now we'll have a DOM tree. Does anyone have any questions about this? I know it's been a little shaky here and there. Yeah, sure thing. It's the same as the one for the React tree, except we don't allow there to be function components. So all we're doing in this first step is taking our JSX calls, right? Which are just objects that can have a type, which can be either a string indicating a regular HTML element, or a function component, which is a function we can call to get closer to what we actually need. And if we call that and we just keep recursively calling all through there, eventually we will just have a tree of things that are only DOM elements. And so that's what this new type. And once we have this, we'll be able to render this fairly directly. So let's go ahead and return this so that it makes TypeScript happen. In fact, we can even just, let's also go ahead and test some stuff because we have done a bunch of things and make sure everything's working properly. So we don't need this rendered to DOM for now. Let's just comment this out. Let's actually just go and in here, let's get rid of all of our console.logs if we have any. Okay. On our first render, let's just take our React tree that we're trying to render and let's convert it to a DOM tree. And see what happens. See if there's any cases we didn't handle or anything that's going to go wrong. Let's get rid of this log. Invalid hook call. Hooks can only be called. Oh, this is because we still in our main app, we still have, we're trying to import this useState from React, but we just totally got rid of that guy. So let's just comment it out for now, which means we'll have to comment out all this other stuff. Let's just delete it. You can add all this back later. Okay. We will write our own useState here in some time. All right. So if we actually log this out, let's see if we can get this to work now. Okay, we got uncaught type error. Type is not a function, but we do get to log something out here. Oh no, this is still, we must have a console log somewhere. Is it in maybe this guy? Okay, true.type is not a function. Let's step into the debugger. Oh man, B is really angry. Cannot access lexical app for initialization. May need to. Okay, let's. Okay, true.type is not a function. Add evaluate tree, line 62. So let's head over there. So what we're running into is that this, in some case that we haven't considered, is not a function. So let's figure out what the problem is. And the issue is that we're trying to call the string hello. So why is this happening to us? If we go into our code, at some point in here, right here, we have the string hello as the child. And because it wasn't just a flat string, right? It's trying to call that because it thinks it's a component, but it's not actually true. So now this is when we actually need to go and handle that case. If we head over to this guy, what is the best way that we can represent that? I think that's the idea behind doing these different nodes. So if this is, okay, so if it's not a function, what we're going to do is return one of these nodes depending on what it is. So let's say, what I'm wondering though is why it didn't fall into this. Because the type should have been a string, right? Let's actually go to the root here. And before we do any of this, let's log out what the original tree looks like and see if we can riddle this out. Okay, Now I think we just have the two calls. Okay, so at first we have, this is right, we have our type, which is an at, which is a function. And then we have some props. And then as soon as we try to evaluate it, what happens? So we walk into our evaluate, we get past the function. This evaluates as it should. And what happens when we actually call the app function? When we call that guy, it gets here to line 16 and calls some component. And some component is going to return, what is this? It's a JSX call. This would be React.grade element div null hello. And so I think what we actually need to do is in our React.create element, maybe get a little more clever here, because, well, there's a few ways we can do this, but the issue is that our React tree, our types are not actually correct, because for our children, they don't just have to be a React tree. They don't just have to be something like this. It could also be just a regular old string. That's why we're running into these issues. So let's add that, and let's add the other things it could be as well. We'll just do string and numbers. We also will need to handle null, because people sometimes try to render null and then you just get nothing. So that's coming. But let's do this for now. Okay, and then let's see what's the best way to handle that. So if this is now, oh, that was the wrong one. Do up here. And maybe it'd be better if we read it this way. So a React tree could be a string. It could be a number, right? Because if you're trying to render a child, like, remember, a React tree is just a React element. So it could be an actual, like this case here, if it's type string, if it's an object with a type string in it, it's an HTML component. If it's an object with type function component, then it's a functional component. If it's just a string or just a number, then it's not any kind of component, it's just that raw string. So that's what we need to handle. And then let's see what goes wrong. Okay, here's what we need to do. If we get, before we even start checking for types, we need to make sure that what we have is not, our tree isn't just a plain old string. So if we have, if that's the case, if we have just a string, or if we have just a number, then we can return, we need to return some representation. So that's what we're doing with our nodes up there that we made before. So our string node, our number node, that's what we're going to use here. So on string node, and this will be kind number node. And then for the value, we'll actually just put the variable in there. And our DOM tree now can either be one of these structures, or it can be a string node or number node. The other thing we want to do, let's add a kind here so that we can tell this apart from the string node and number node. So now they all have dot kind, and what this will let us do is anytime we have anything that's a DOM tree, regardless of which tree it is, we can dot kind into it and check that. Okay. And now we're saying this is not assignable to DOM tree. Oh, this is because we need to add our kind that we just made and HTML node. Okay. Let's see if we have better luck with this. Okay, that's good. Nothing crashed. So first this first line is our initial tree, which has type app. But after we pass it through this evaluate, it's unwrapped everything into the actual children. So we can actually read what is trying to be rendered from the real app here. So at the top level, we have a type div, and it has children. And we have what, another div. And then we have what, 4 more divs in H1. Let's go back to app and remove some of that like random stuff that we put. So it's not as big of a problem. We can just kind of see the base stuff. Okay, so we have HTML node. So we have our div. Inside of that, we have a div in H1, a div, and a paragraph, which is what we have here, right? So we have a div in H1, a div, and a paragraph. And if we open those up, we'll see all the sub-requisite stuff in it too. If we want to open up, let's open up this second div and see, make sure that everything's right in there. So inside of this guy, we have more children. We have a button and a p tag. We have a button and a p tag. And inside of the button, we have a string node with click me, which is what we have here. So does everyone have it working up to this point? Who's following along? Yes, do we have anyone on Zoom? I haven't checked Zoom chat in a while. Okay, sweet. All right, so we've got this. We're able to convert our React tree. And this is actually how React will render our stuff out. So every time React re-renders the page, it goes through this process of just recursively calling through all of your components. So every render, all your components functions are recalled. That can be useful if you're wondering why there's certain, like, why does React have weird things like useState and all of this going on? It's because when you declare a variable in a component, it's not like that component gets called once and then magically stuff gets updated. When that component changes, the whole function is getting recalled. And so if you just had a regular variable and you said, oh, let a equals 5, when you recall it, it would just get set back to 5 immediately. It doesn't matter if you changed it in the past, right? So that's why you have to do things in this interesting way. So now that we've actually created a DOM tree, let's work on rendering that out. So that's what we can do with our render DOM. So we'll take our React tree, give back an HTML element, and we need to handle some cases. Okay, first we need to handle, let's handle our string node and our number node because those are the easiest. So we can check that kind that we created. If it's string node, what do we do? We're just going to go and create a text node with that string in it. And this needs to be DOM tree. Okay. And then we'll just return that guy. And up here, we need to recognize that we can not only return HTML, but we can also just return one of these basic text nodes. Okay. We can actually just pare this down to this. What's our other case? If it equals number node, we do a very similar thing, right? The only difference is if we have a number, we got to convert it to a string. That's pretty good. And then the last case is if we have an HTML node, which is all the rest. So that's when we can start introspecting the type and figuring out what to do. So we don't actually have to do this function because we already did this. We know this is always true, so we don't have to worry about this. We should just be able to do this and pretty much be good. So let's try this and see what happens. And we didn't actually render the node into the DOM anywhere, so let's do that here. So let's get rid of these. Let's store the value of our rendered tree. So first, we're going to take our React tree. We're going to evaluate it to get the DOM tree. That is just DOM elements. And then we're actually going to render that into DOM elements. And then let's just insert that into our root element. Maybe. Give a blank div. So if we look, we just got a blank div rendered in here. Why did that happen? Well, the issue is we're not doing this render to DOM recursively either. So when we actually display the, like our very first thing, our whole app is just a div. So we created a div and we returned that div. But what we actually also need to do is walk through all the children and put them into this element we just made. So we can do that. Let's first unpack some of the stuff from this. So let's get our type and get our props out of our element. We can just do type here. Or this should be what, tree. And then our props, we can actually unpack further into, we want those children now. And now we can have our rest props. So we're going to iterate over all of the children and call this function. So to do that, you can just do a for loop. I'm just going to do .map. So if we map and we map this function here. Or let's call this rendered children. So now we actually have real DOM elements. We have a list that has HTML elements and actual text nodes grabbed out of there. And what do we need to do? We need to put them inside this element we just made, right? Because they're children, they're supposed to be children of this thing. So what we do is we can just do append, and we could do a loop and do append child on all of them, but there's also this useful helper called append that just lets you have a whole bunch, put a whole bunch. So we can just do this. It expects the weird, like, it expects you to put each element as a separate call instead of just passing the full array. So you got to put ... like so. And now, with any luck, we should be able to get to work. I'll give you guys a minute for people following along. One thing is this rest props, right? What are we going to do with the rest of these props? So right now we're not rendering any props onto the actual elements. So what we're just going to have is an empty tree with all the children populated, but no attributes are actually set in our HTML. So that's what we need to do next. Okay, let's take a look and see if this actually worked. Okay, not bad. We've got some basic stuff deployed. So you can see our Vite plus React, see our button. We can see the strings and stuff rendering in. Some of our stuff is not going so well though, like our links. Why is there nothing here? Well, it's because they were links. There's those images. In order to actually, for the image to show up, we have to add that href attribute. Right, so let's handle that next. So after we render the children, we need to deal with the rest of these props. And what actually are the rest of these props? If we go back to here and log out what our rendered tree, like let's log out what the evaluated tree looks like. So pass it through. If we go back and actually log out what that looks like, right, there's some important props. Like if we drill into what that, the very first div that has the images in it, right, here's our links. And some of those props are href vite.js.dev. And so that we need to actually include that href on the image for the image to actually show up. And so what we're going to do is inside here, before we actually put the children inside, let's set all of those properties. So basically we can do, this is a nice pattern you can use for when you're trying to iterate an object. You can do object.entries, and it will present it to you as a key value pairs of the things in the object. So in this case, our object is going to be those rest props, right? All the other things that are part of the the props. We're going to go through those by key by value. And for now, let's just log those out. So we can actually see what they are, because there's some interesting ones that we need to do some things to work around. All right. There's a whole bunch of different things here. We've got underscore underscore self, underscore underscore source. These, I don't think these actually show up in production React. They're just some helpful things that are included. I think it's like source maps and stuff, so that if your app crashes, it can trace its way back. But here's our href.js. Here's our target underscore blank. So some of these other properties that are being set, right? And where are those coming from? Again, they're coming from here. So we have our href.js, target underscore blank. We need to actually set those. So what I'm going to do, this is a terrible hack, is anything that starts with underscore underscore, we're just going to ignore, because we don't want to render those in as attributes. So let's do that. Let's make sure that gets us the results we expect. Oh, here's another thing that might be important to notice. So you see this class name app. In React, you know that because JavaScript already uses class as creating a class, you can't use the class keyword in JSX to add CSS classes, right? So normally we open up our app here, right? Normally, if you're just doing regular HTML, you would just set class equals app. But since we're using JSX, we got to do class name. And so we got to convert that back so that nothing blows up. So that's something else we need to handle. But let's look at the rest of these and see if there's anything that looks out of the ordinary. The rest of this looks like it's probably good just to drop straight on to our element. So let's handle the class or the class name. So if it's class name, what do we want to do? We can actually just set element.className equals whatever is in there. And it's going to say type unknown is not assignable to type string. This is because this value could be anything, right? Technically, people could put things other than strings. So let's just call string on it, just to be extra safe. Then if they pass an object or something, they'll get object, whatever in the logs, it'll be okay. And then our last case, if it's not underscore underscore, which we just throw away, it's not class name, which we convert, we just set the class name like this. Let's just set the attribute directly. And there's a useful DOM function for this, set attribute. So we literally just do this. It's going to expect this as a string, so let's make it a string. And with any luck, there we go. We now have gotten to the point where we can render our initial page. So it's pretty good. But we are trying to do React. How do we make things reactive, right? This is where we need to start pulling things like useState. So the next goal that we want to, like mini goal we want to achieve. Let's add the counter back to the click me, so you can click the button and have the number go up. In order to do this, right, we have this count, right? So we need this useState function, and useState's a very interesting thing, right? It takes in a default value for that it'll initially be, and then it gives you back an array. The first thing is a read-only copy of what the value is supposed to be, and then a setter to update the value. And then down here, let's go back to our button and add on click. So what was that? Set count. Okay. Set count plus 1. This will increment the count. And then let's just do count is currently, and just interpolate the current value right there. Now, the first issue we're going to get is cannot find useState, right? We uninstalled React, so we need to make our own useState. So we will provide a useState. Now we need to go over into main.tsx and actually implement that. So let's do that. And what is the type of useState, right? What is the useState function? So we can look at how it's used and sort of figure some of that out, right? So it can take in, what is this value? For people who know React, this value is just whatever the initial value is. It could be anything. So let's take in that. So we have, initial value, could be anything. So we'll mark it as unknown. Are there any other parameters you can pass useState? Not really, you just pass the one. So this, that. And what we can do for now is let's just make a blank state that is nothing. And then when useState is called, let's just save it to that global variable. And then the other thing we need to do to fulfill the full contract of useState is we need to return back that array. We need to return whatever the current value is. We need to return a setter to update the value. So how do we actually do that? Basically, it's going to be like a value, and we don't know what the type of the value is. So let's actually go ahead and make this guy a generic. So it's parameterized over type T, right? Because this initial value could be anything. We're going to give back something presumably of the same kind. And then we're also going to give back a setter for that. And I'm just going to write a little setter helper type. What is a setter? A setter is just a function that takes something of that type and then gives you nothing back and does the set. So now it's angry that we're not actually returning that. Let's actually return that. So let's just return the state. And then let's return a setter for the state. So the other thing we need to do is, because every time, remember, when we re-render the component, useState will get called again. So we can't just assign the initial state in every time. We can only do it the first time. So let's just make a flag to indicate if we've done that already. So if first time, then we'll initialize that state. Otherwise, we just don't do it. And after we do it the first time, we set that guy to false. If it likes this. Oh, it doesn't. I'll just mark this as any. Okay, pretty good. Let's see if this works for us. See if we have any compilers. This appears to be okay. I think the dev server is just really freaking out. Okay, nothing's exploding. Count is currently 0. And when we click it, nothing happens. Why does nothing happen? Well, when we click it, the value, let's first make sure the value is actually getting updated. So useState isn't getting called again. Why isn't useState getting called again? Well, we need to actually have some way to trigger this render to happen again when that click happens, right? The other thing that we're not doing is we're not actually handling this on click. So if we look at what's happening here if we actually look in our, let's inspect this button, on click needs special handling, right? Because right now, okay, well, it has converted into an on click with a function inside of here, but we really don't want to be setting the attribute like this. If you've done JavaScript click handlers, what you want to do is add event listener is the best way to do it. So what we need to actually do is change our rendering here and say, let's add another case here. So if we have an on click, and regular React basically does this for every possible on event. So we're just going to do on click here, but there's on double click and on all the other things. So if our key is on click, then we're going to do element.add event listener click. And then whatever that value is. And we'll just do as any in order to bypass the type system. If you pass us not a function, this will all blow up, but that's okay. It's just a prototype anyway. So now if we actually reload this, you can see our button has an event attached to it instead of having that on click with a string in it, which is much better. But still, we click this and nothing happens. So let's check and make sure the click handler is getting called. So let's just go in here, add a console.log. Make sure that's happening. So I clicked it. It says it got clicked. So it got clicked. It's calling set state. But this is sort of the magic of React. So when we call the set function, that React uses that as a signal to know that the UI needs to be redrawn. So even though you're calling this function and state is actually being updated, like if we go, let's go back into here. Let's find our setter. All right. So if we go down to here, in this, let's console.log setter called. This is getting called. The state is being updated. We're just not seeing it reflect in the UI. So see, the setter is getting called. We're updating this variable in JavaScript, but the DOM doesn't automatically update, right? That's the abstraction React tries to provide for you. This idea that when you update state, magically, it just gets updated in the UI, but we have to actually implement that. And so what do we want to do to make that happen? When basically whenever we call a setter, what React will do is re-render the UI, the entire thing, all the way from the top to the bottom. And so what we'll do here is we'll update the state, and then let's create a function that will just do a re-render. So re-render. And what are we going to do? We can just copy this, copy some of this code here. Let's actually extract some of this stuff out so that it's a little bit easier to deal with. So we grab this. Root. Let's say that's our root. And then when we re-render, because we actually did create a React. I think we did create a React DOM.create root. Oh yeah, so it's right here. When we actually want to re-render, we just want to call this same render app again, basically. So let's actually just move this whole shebang up here, or we can move this all down here. Maybe this is the easiest way. So here, let's do React DOM. I'll create re-render all this. Okay, so now we'll have the actual React root. And we call root.render here. And when we re-render, we also are going to call root.render. And we need to pass in our React tree. So do this. And now, whenever we update our state, we're just going to do a set timeout 0. So if you haven't seen set timeout 0 before, this is basically just queuing up something to happen the next time the browser isn't doing anything. So let's just re-render at the next available opportunity. And we'll give this a try here. Load this, we click this. Ooh. So it sort of works. This is because we're appending instead of replacing the old UI. So what we really need to do is when we're appending child here, we need to replace. And so probably what we want to do is do like another thing where it's like first time is first render. Put that to true. The very first time, we're just gonna append child. Let's first render. If it's not the first time, then we're going to do basically the same thing, but we're just going to replace instead. So I guess really we can just extract this out to here. Oh, and we need to pass. We need to do. Expects us to do. And here we go. Let's do this. Replace all nodes with nodes. Yeah. Replace children. Let's try this. So, oh, maybe not. Oh, we don't set is first rendered to false. Okay. Try this, and now we have a button that updates. So it's pretty good. It still has some issues though. So when we press it, you'll notice the image like jerks. Why does that happen? The reason that happens is we're redrawing the entire DOM every time anything updates. Real React doesn't do this. So even though this image doesn't actually change, and the only thing that changes is this little 20, right? If we look here, like if we try to select one of these elements in here, we click this, you notice it all collapses because everything got swapped out. We removed the entire DOM tree, remounted the entire DOM tree. And Real React doesn't do this, not just because of it will cause your spinning images to stop working. That's obviously bad. But also it's super inefficient. So one of the core design ideas behind React is that you only do like a surgical update. Instead of redrawing everything, just redraw the one thing that needs to be done. So if you were actually writing this code in an imperative style and you weren't trying to use React, what would you do? You wouldn't regenerate the entire tree and redraw it. You would just go and set the text on that one button to increment by 1 and leave everything else exactly the same. So how does React actually do this? Well, they helpfully document it under this page called and it's called reconciliation. So what they do is they basically do a diff between the old tree and the new tree. So they generate, you keep track of what the old tree was. You generate what the new tree should be, and then you try to figure out what is the minimal operations we have to do to convert the old tree into the new tree. And this is pretty difficult. It's actually order n cubed to do it perfectly, to actually get the minimal sets of stuff, which is bad. You can't actually do that. And if you have enough elements, it's going to be problematic. So what they say is they do some heuristics. They do some basic stuff to say, listen, if we do take a couple of shortcuts and we maybe don't do it the most efficiently, but we get pretty close, we can get rid of the order n cubed and be in much better shape. So one thing they do is if an element type changes, they just throw away and re-render that entire subtree. So if you have a subtree with a div in it, and then on the next render in that same location, there's a span, they're like, they don't go and try to compare all the children of those and like figure out if they can save some of them. They just say, okay, we're going to throw away the whole div subtree, render the whole span subtree, and plop that in. So that's one thing they do. The other thing they do is when a DOM element is the same type, they only update the attributes. So if you have a div and one of the attributes changes, they don't re-render the div. They just swap out that one attribute value. They just basically call set attribute in the one thing. They do some things with style. And then the other thing they do is this is why React lists have issues. So if you just think about this, if you have a list of children, you take a look at that, you'll take a look at another list, and there's changes. How do you find the minimal diff to convert between those two? That's a pretty hard problem. So what they do is they just compare the first child of the first one to the first child of the second one. And then the second one, the second child of the first one to the second child of the second one, and the third to the third. And they just do any swaps like that. This is great for appending because you'll say, oh, look at this. We've got first, it's the same. We've got second, it's the same. We've got nothing, we've got third. Okay, add third. When it's not so good is when you put things at the beginning, or if you like sort or do other things like that, because then it's going to say, it's not going to notice that you inserted this at the beginning. It's just going to say, oh, look at this. This is Duke. This is Connecticut. Okay, re-render that. This is Villanova. This is Duke. Re-render that. There's nothing. There's Villanova. Re-render that. So you get a lot of extra re-renders. That's why if you render a list in React, you'll often get that warning in the log that says, add a key prop, right? Have you seen that before? The reason you have to do that is if you add a key, React can look at the key and then match up the keys across renders and save the element instead of redrawing it. So you don't have to do it. It's just terrible for performance if you don't. So that's that. So we don't have a ton of time left. So what I'm going to do is let's write a basic implementation of useEffect, which is kind of the other main hook. And then we will see how far we can get on writing the reconciliation algorithm. It is all helpfully documented here, and I will post the code later today. So if people want to take a look at sort of the final thing, we can do that. But let's write a quick useEffect. So if you haven't used useEffect before, useEffect lets you make other kinds of updates aside from just DOM updates. So if you want to, like an easy one they often use is setting document.title, right? So document.title is what the tab title is. So you can set this using document.title equals something. If you want to do that on every render, you can use effect. So let's say we just set the title equal to the count. And we have to convert to string. Let's do that. And we don't actually have, we need to import useEffect. Do that. Oh, it already imported it for us, but we don't want this. That's not going to work. So make our own. And then there's also a dependency array. Let's not worry about that for now, but we'll see what it's for in a minute. So let's go back to our main file and let's write useEffect. So useEffect is a little bit trickier. What does it take? It takes a function. So I'm just going to take that as any to save some time. It also can take an array, but let's not worry about that. We just want to get a very basic implementation of it going. What useEffect actually does, if you read the docs, is when useEffect gets called and you're in the context of rendering some kind of component. So when you render that component, once all rendering is complete, we want to run any effects that need to be run. And so basically what this entails is let's just keep a job queue. So like, let's say we have a task queue of stuff that needs to happen. And when we call useEffect, let's just push another task onto the queue. So we'll just push that onto there. And then at the end of our render, we need to run all of those tasks. And so what I'm going to do is make this re-render. And here, after we actually render the app, while we have items in our task queue, we're just going to pop off the item from the front, right? And so the way you do that is, I believe it's .shift. Remove the first element. Yep, so we'll do that and then call it. And eventually we'll have emptied the queue and done all of the effects and should be good to go. So let's try it. Okay, so you can see it worked on our first render. If we update things, it'll also update that. So that's all useEffect does. Just schedules work to be done at the end of the render. The other part of useEffect is the dependency array. So to code that up, we'll have to add a couple more things. But what the dependency array basically does is it will avoid rerunning the effect if the dependencies of the effect haven't changed. So basically, in this case, even if count wasn't updated, like something else re-rendered, we would still rerun that effect, which in this case would have no ill effects. But sometimes if it's something performance intensive, like you're doing a fetch, that can be problematic. And so what you want to do is avoid doing that. So that's what the dependency array does. In order to implement that, though, what we really need to do is implement the ability to have multiple state values. So right now, our useState kind of has this problem that it only encompasses one state. As soon as we try to go and do more states, we get ourselves in a lot of trouble. So if we go here, and let's just make another count variable, count2. Right, and let's make another button that just does count2. So if we update one, it updates both. That's not good. So how can we solve this? A lot of people often wonder when they see useState for the first time, how is this useState separate from the other useState, right? It seems like a tough problem because it's the same function. You can't tell based on the argument that's passed in, because in this case, we want to create two separate counters that both start at 0. So it's not like you can like see, oh, the initial value is this, so I know it was that one. It's not so easy to figure that out. And so what they actually do is they just keep an array, and they just keep an index. And that's where all the rules of hooks come from. So if you go into the docs and you go and let's see, let me find the hooks, right? They have all these rules that you have to follow. Rules of hooks. So you might wonder, why are there these strange rules? Only call hooks at the top level. Don't call hooks inside loops, conditions, or nested functions. Wonder why you can't do that. Only call hooks from React function components. Don't call them from regular JavaScript functions. Why can't you do that? The reason you can't do that is because it will destroy the ordering. Like you won't be able to predict. The only way that this works, what they do for the state is they just keep an array and they keep an index. And every time you call a hook, they increment the counter. And they know that the next time you call it, you're looking for the next thing. And so if you call it conditionally, then how do they know if you increment it or not, right? They can't match it up. If you call hooks in a loop, same problem, right? They don't know how many there's going to be. It could be different each time. And so that's going to mess it up. So that's why you can't do any of these things, because they're just using an array and a count. So let's implement that. We'll also need to make this like initialized array. What we can do is we can just index the array and check if it's undefined. So if you index a JavaScript array, you'll get undefined by default, and we just hope they don't store undefined. What you probably would want to do is use a separate array so that if they do put undefined into the thing, it's not going to explode, but it's fine for our use cases. So if state.index is undefined, so we index into that state and get it, then what we're going to do is set it to the initial value. And in the future, it won't be undefined for that reason. The other thing is at the end of this hook, we need to increment index for the next one. So that should be pretty much enough. One other thing we'll need to do, but we'll see in a minute here to get this mostly working. So now we increment this one. And oh, nothing happens. That's not good. Let's see. And now our issue is here. Instead of returning state, we need to return state at the index, at the given index. So what I'm actually going to do is copy the index so we can just increment it up here without problems. So go ahead and do this. And when we update it, we also need to update it that specific index. So we need to remember that inside of the function here. Should work now. See. Oh, trees undefined. That's not good. Trees undefined. Initial state is undefined. Oh. Okay. And now, So when we click these, something's happening, but it's not actually updating the values still. The other thing we need to do is reset our index. So at the end of the first render, the index never, like we never reset index to 0. So we just keep ticking it up more and more. That's why this happens. So in our re-render, the last thing we need to do is, well, or we can make it the first thing, is we'll just set our index to 0. Now it should actually work. So now you can update this one, you can update this one. They update completely independently. Do we have any questions or comments or anything else so far? The last thing we're going to try to do is see if we can get the reconciliation algorithm implemented. And that will fix our issue with our image not spinning correctly because we won't be redrawing the image. To do this, let's just follow along with the documentation that tells you what to do. So let's make a separate file, or let's go ahead and go to the bottom. Let's make a separate file for this. Reconciliation, that looks right. So what is this function going to take? First argument will be like an old tree. And what we really want to be diffing is the DOM trees. Because if we try to diff the React trees, we get into a situation where we have the app function and we have to diff it with a different instance of the app function. And it's like, how do you do that? You can't really do that. So let's see. Why are we struggling to import this? Probably because we didn't export it. Yeah. Okay. So we take an old tree, which is a DOM tree. We have a new tree, which is a DOM tree. And what we need to do in this function is just figure out, okay, how can we take our old tree and convert it to our new tree? So let's handle the basic cases first. We could have elements appearing or disappearing. Right, so if that's the case, like this guy could be null technically. So let's go add that to the actual typings. So people know that's possible. So this React tree here could be null. And that means this DOM tree could also be null. And so now we need to fix that. So if tree is null, then just return null. So here, what do we want to render if tree is null? Nothing, right? So we'll just send back null. And then when we actually draw it, we'll just do nothing. So we need to add null here to our types. And then we have an issue here where we might have to render null. Our list of rendered children could be null. And so what we can do is just filter out anything that's null. So if it's null, filter that guy out. And then we can just TypeScript, it's okay. Same thing here. We could, this is for our initial tree. So if our initial tree turns out to be null, then if we can't append null to the DOM, but we know that won't be true. So let's just bypass that. And same thing here. If our new tree becomes totally null, let's not worry about those cases. You can handle all of those if you want the most robust implementation, but not a problem for us right now. Okay, so here are with reconciliation. These guys could be null. So first, if the old tree is null, what do we do? Well, that means there was nothing. And maybe there now is something. So what we really should check is if this is null and the new one is also null. That's the easy case. If we had nothing and we still have nothing, then we just do nothing, right? We're good. If we had nothing, but we do have something, then we need to add said something in. We don't have to do anything about the old, we just add the new. The only issue is where do we actually add the new? Well, what we need to do is basically append child it to the parents. So we also need to pass in our parents, which will be an HTML element. And so for that, we'll take our parents and append child. Tree. And then we also, for this new tree, we need to actually render this. So what do we call that function? Render to DOM. It's exports. So we'll just render our new tree to the DOM and add that. What is it saying? It's saying, oh, when you render this to DOM, it could be nothing. Fair enough, but we know that's not true because it's only nothing if we pass in nothing. So we might be able to actually just take this guy off. Maybe. No, maybe not. What we can do is we know that this new tree, we already checked it wasn't null. So if we render something that's not null, the result will surely not be null. So we can just use this exclamation point to tell TypeScript that we know this is a theoretically unsafe, but in practice should be fine. Okay, so we had nothing and we had nothing, we did nothing. We had nothing, we have something, we rendered the new thing. If we had something, but now we have nothing, we should just remove what we have. So I don't know if there's a better way to do this, but what I've been doing is just grabbing the parent node. You can use a node to grab the parent node and then calling remove child on the parent. This seems to be what you're supposed to do. I'm surprised it's not just a like element.remove or something like that. The only issue is that we don't actually have a reference to that node. And so what we need to do is go to our DOM tree and add a reference to the node. And it won't necessarily be initially populated, but as soon as we render it, we can add it. So we're just going to set it to, we're going to make it optional and then just use a lot of exclamation points when we know it's safe. There's probably a better way to do it, but should work for our purposes. What we do need to change is our render to DOM. So when we actually render something to the DOM, we need to modify our tree to add that thing so we can get at it later. So let's do this. So we'll return our node. And then what we need to do is do tree.node equals that node. And oh, we need to add it to string node. So really what we can do is, we can do this. Well, let's just leave it like this, just to be safe. Okay. So we're adding it into the tree. If that's the case, we need to do the same thing here. Just need to call toString. This is the same thing. So at the end of all of this madness, when we create this element, let's set the node equal to our element before we're done with everything. And I think for any children, it should be fine because when they actually get rendered in the recursive call, they will either be a string node and they'll assign themselves, a number node and they'll assign themselves, or a regular node and they'll assign themselves. So what we can do is take a look at our console and make sure that all of the nodes are added. So here's a node here. There we go. That's been attached. And our children, there's also a node attached. Okay, seems like it worked. Let's actually take a look at one text node to make sure that didn't explode. So take a look at the children here. Oh, this is the A tag. This is the wrong one. Let's look at the P. Ops. Children. Okay, string node. And yeah, we have a text node attached onto that guy. So great. Seems to have worked. So now, if we go back to our reconciliation, here, we can actually get at that node. So we've plugged that node into the DOM tree, so the old tree will always, we know for sure, have that node attached. So we can grab that. Why is it putting a question mark there? Object is possibly null. Oh, we need to return here. Okay. Yep. So we're going to grab that node. It thinks it could be undefined, but we know this is not true because it's always set. So it's safe to do the exclamation point. And then we can take the parent element, and then we can do remove child. And we can just remove this. And also thinks this could be null. Okay. So now if we had nothing, we did nothing. We had nothing, we inserted our thing. We have something, but now we want nothing. We remove what we have. The last thing we need to do is, what if we have something and we have another something, possibly the same something? This is where it starts to get dicey. So let's unpack some of our values so we don't have to dot into so many things. So let's grab our type out, and this is all coming out of our old tree here. So what else is in our old tree? We could grab the kind. That might be a good thing to do. So let's grab the kind. See, we don't necessarily have the type. So I guess probably what we should do first is handle the cases. So if our old tree is a string node and the new one is a string node, that's great, because if they're both strings, then all we have to do is compare the strings, and if they're different, swap them. So if we have a value, if we have an old value, because we know they're both strings. So if they're both strings, the values aren't already the same, then we just swap it. And so what we can do is just say, okay, go to the old tree, go to the node, do inner, we not do inner, we have to put question mark. Why is it angry? Maybe this is why we should make the types correct. Let's go back and fix the types. We know this has to be this. And we know this has to be this. Is it text? Oh, it's text content. Never mind. Okay. If we want to set the content of that thing, we can do that. We set it to the new one. And, oh, it may not be an optional. Yeah, you can't do this. Okay. We know that that node will be there. Okay, so we update that. The other thing we need to do, make sure that we do, is throughout all of these, anytime we insert something new, like for example here, we create a new element. In order to make sure our new tree maintains the invariant that there's always nodes in the node value, we need to assign that. So what we can do is we can say new tree.node equals this. We need to make sure that we save these nodes that we're creating so that the new tree will still have the next time this runs on the next tick. Object is possibly null. Let's see. Tree. Oh, I guess we can do. That will fix that, but then old tree could be null. Wait, so if they're both null, if new tree is null, what do we do about old tree? Now then we know this has to be here then, right? Yeah, it's just the TypeScript can't figure it out. Okay. Yeah, because if we checked that they were both null and that wasn't true, and new tree is null, then that means this wasn't null. Yeah, I don't know why I didn't pick that up. Okay, so we do that. We need to save that node, and then we append that node. Okay, here it's the same thing. So we need to make sure that we save. If we don't create a new node, we still need to copy the node from the old tree into the new tree. So since we're reusing that node, we need to set new tree.node equal to old tree.node. And then we should be good. We do this down here. If there wasn't any changes, we don't do anything, but we still need to do this regardless. Copy that node for the next iteration. Okay. What's another possibility? They could both be number nodes. That's pretty much the same code. We just make sure we convert it to a string. So There we go. Great. They could both be HTML nodes. So that's a possibility. And then what's the last possibility? They could be two different kinds of nodes. So let's actually handle that first because that's a little bit simpler. So if the kinds aren't equal, what do we do? Well, as remember in the reconciliation, right? If we have elements of different types, right? We have a div and then we have a span now. We just tear down the old and bring in the new. So let's render the new thing. So we can say our new tree node will be brand new node. So render to DOM, our new tree. Let's see. Oh, it doesn't like this. This could be null and this could be undefined. What we can do is, that's terrible, but it works. Okay. So we generate our new node. Then we need to actually swap out the old one. So old tree.node. And there's actually a replace with method. So you can replace a node with more nodes. So we'll just use that. And need to make sure we know it's not null. Okay, that works. Okay. So those are the most straightforward. What do we do if we have two real HTML nodes? There's two cases. If the types aren't the same, right? So if the type of the old one is a div, one is a span, same deal. We need to redraw everything. So let's do that. That's the easy case. Same deal as this. Checks is missing. Oh, it's thinking this could be a text. Let's just cast it. Should be fine. Okay. If they're not the same kind of HTML node, we just tear down the whole tree and replace it with a new one. What if they are the same kind of thing? This is when we do that attribute by attribute fixing up of stuff. And it will be useful for us to have our other code up from when we actually did that thing. So basically this loop right here is more or less what we need to do, right? We need to run through all the attributes, compare them, and kind of remember to do all these same things. So I'm going to do this. Or actually, there's a couple different ways we can do this. Stop this. I think what I'll do, iterate. The issue I'm running into is if we add, like a new prop gets added, so we only had 3 props before, but we have 4 props after. How do we make sure that we account for all of that? So let's just loop through. Let's just loop through the props. So let's grab the old tree props. So if the new tree, so if we look up, we're going to use the key from the old tree, look that up in the new tree. If it's not the same as the value in the old tree, then what we need to do is swap it. So we'll do set attribute. Because we're going to maintain the same node. So tree. This will update it to the new value. Okay. If they are the same, we just do nothing. The other thing we have to do is we have to handle the special cases, right? So all of those, if it's underscore, we need to continue. If it's on click, we gotta do something. If it's class name, we gotta do it different. So let's grab all that code. So if it's again, if we have underscore, we're just not going to worry about it. If it's on click, well, we need to do something that's a little bit different. So we need to first remove the old on click listener, right? Because there would have been another one. So we can do remove event listener. Oh, we need to rename this. So old tree.node. Old tree.node. Okay, so remove the old event listener. And we need to remove, and what you have to pass for the second argument is what the listener actually is. So I guess they just do a reference check or something. So we'll pass the old one in, and then we need to add a new one with our new value, which will be new tree props props key. Okay, if it's class name, it's fine. We just reassign the class name. So this, and we want to make sure we have the new value. So new tree props key. Okay. And then here's our last case to reset this. I don't think there's anything else we need to worry about. Do object.entries. I think this should more or less fix our problems. So let's try it. But it's still redrawing the whole app. So the issue that we have here now is we need to update our code in our base in here to not re-render the whole thing, right? So instead of doing this, the first time, sure, we render it in. After that, we're not going to just replace the whole tree. We're just going to call reconcile and hope everything works fine. So reconcile should do all the work. Instead of just hot swapping the entire UI, reconcile should be able to walk down, check all the things, and do the appropriate stuff. So we'll pass in the old tree, which means we need to store the old tree somewhere. So let's do this. And really what we want to store, I think, is the evaluated tree. Yeah, so because we just want that data structure, right? The evaluated tree, remember, it's our DOM tree. So this is what we want. This is what we want to compare. We don't want to try to compare like HTML elements, and we don't want to compare this because if we have function components, you can't compare functions. There's no way to do that. So we'll do that. So now we have our old tree. Reconcile our old tree with our new tree, which will be our new evaluated tree. What is our issue? Oh, expected 3. And we need to pass in a parent, remember, at the very top level, in case we need to add a new element. So we'll just add our root DOM element for our parent. And, oh, I don't think we handled children, so it's probably going to explode. That may be the last thing we need. Let's see. Yeah, because we didn't re-render the children. We didn't reconcile the children. We just stopped after one level. So that's our last thing we need. So that's also going to be here. So what we really need to do is for the props, basically, we need to do a check if the key is children, do the right thing, right? So if we have children, what are we going to do? Basically, recursively reconcile one-to-one. So remember I was talking about if you have the two lists, what you do, the naive algorithm, we're not going to check the keys. We're not going to use let you use the key. So do that. We'll just do regular old for loop. And we'll do old tree dot props dot children dot length. And just reconcile the old children with the new children. So the old child would be old tree dot props dot children I. And the new proposed child would be same thing, but with new tree. And then what would the parent element be? The current element, right? And so it would be old tree dot node. We have to mark that as not null. The other thing we need to do is if there's any new elements at the end of the new tree, we need to make sure that we do those. So, right, let's say there was 3 elements in the old and there's 5 in the new. So we're going to compare the first 3 and then we're going to just add whatever the other ones are. So same thing here. And we'll just do tree dot node dot append child, or we can do the dot append with a list, and we'll take the new tree children. Actually, it's easier just to do it like this. Yeah. Props dot children I, and we need to render this. And there's no point in trying to reconcile it because we know that there's not a corresponding element that exists already. To do that, and hopefully it will work now. Let's see. Oh, shoot. What are we missing? We probably have one case that we're missing here. So in our new tree, let's look at that count, which is in this div. Now here we are. Oops. Yeah, is our state updating? Let's see. What is our issue here? Are we not updating on click? Maybe that's what we have wrong. Oh, we are so close. It's children. You know what? Maybe we need to do this. New tree.node equals. We need to save our newly created tree there. Missing something. useState was called. Why is useState not returning new value? Let's see. Wait a minute. So we get 0, 0, 0, 1, but then it doesn't update the thing. Are we missing? Let's try this. function evaluate tree, but whole tree shouldn't be. Function evaluate tree. That's not good. Why are we getting? Oh, there we go. This is why you don't use any. Okay. Let's see if it works now. Okay, there it works. And if you look, it's not causing that to re-render. And you can check in the DOM in the console too. When you click the buttons, it only updates. Oh, it actually looks like it's updating the other one as well, but it doesn't update anything else other than the counts. All right, here we go. Any questions? It's a bit rough, but we made it. I spent a lot of time over the last several days working on this. So, all right, let me pull up Zoom. Everyone left Zoom. Sweet.